Hello everyone, my name is Ron Heiler and I will be your host during this technical series. This series is going to be one on game engine design and implementation, coding basically. So yeah, I've got a fair bit to cover, so let's get right to it. So I'm going to use Word just to kind of go through this series. So this is going to be game engine design and implementation. Implementation, if I know how to spell. Word 1. All right. Whoops. That's not what I wanted. All right, let's bold that and underline it and make it big. There you go. All right, let's go back to something more reasonable. All right. So the intro. Actually, we'll bold and input that as well. First of all, let's talk about the motivation for this series. Why do I feel like I want to do a game engine design and implementation series in the first place? Well, there's a couple of reasons. Maybe even 3. So there we go. Why? There we go. First off, I really enjoy technical series videos. Now, don't get me wrong. I love doing the game series. They're a blast. They're a lot of fun. But I find the ones that I personally most look forward to really are the technical series, the ones where I'm explaining things, or trying to teach to people who you know might be interested. Now, I don't want to come off like I'm the foremost expert on game engines. I certainly am not. There are plenty of other people who know a great deal more than I do about game engine design and implementation. Some of them who do this kind of thing professionally. I have a great deal of respect for these people, but I do have some experience in this field, and I think I have something to offer as far as teaching goes. So we'll put on for the first point, because I enjoy teaching technical content, right? The second reason is a little bit more selfish, I guess you would say. So I've been a coder for practically my entire life, since I was, since my family first got a Commodore 64 way back in the, early 80s, I guess. I started off with BASIC, I think like pretty much everybody does. From there, I moved over to assembly language for a while, and then from there, that was right around the time that C came out. So I moved over to C, programmed in C for a very long time, and kind of naturally moved over to C++ as that language developed, which is where I spent a great deal of my programming career. In recent years, I've moved over to C# quite a bit, just for reasons. Not that I don't like C++ or think C# is a better language. In a lot of ways, it is a better language. In other ways, it's not as powerful as C++. Of course, these are all my opinions. However, in the last couple of years, or less than that even, maybe, last year or so, the nature of my job has changed. I've become more a managerial position. I run other people. Not doing a whole lot of coding lately, to be honest. And I can tell my coding skills are starting to rust, which concerns me. So that's the other reason that I would like to get back into doing some coding, and in particular C++ coding, because I haven't actually done any C++ coding in a couple of years now. And actually, during that time, C++ has undergone a few changes. I think, let's see, it was in 2011 that kind of I wouldn't say a new version, but some enhancements to the language came out, some pretty significant enhancements, which I have not hardly ever used. It was probably around 2012, 2013 when I started moving over to C#. And at that point, the enhancements really hadn't taken hold yet. Not all the compilers had actually caught up to the new specifications. It takes a while for them to do that. So anyway, so yeah, the second one is to let's see, de-rust my programming skills. So let's talk about the language that we're going to use, C++. So again, C++, so series. Let's do that. Why C++? When you're dealing with a game engine, one of the primary concerns is going to be speed, basically. Whenever I talk about the cost of something, what I'm really talking about is number of cycles, or to put it in a little more layman's terms, the amount of time it takes to run a function or run a particular thing. Because what we need from an engine is speed. Things have to go very fast. The game designers themselves are going to be putting in a lot of very stressful functions, and we want those functions to go as fast as possible because we want to maintain a consistently high frame rate during the game running process. And C++ gives us the ability to go fast. It's a very low-level language. It's just a step above assembly language, basically. Now, we could program entirely in assembly language, but nobody really does that anymore. There's not really any need, except for the really low-level stuff that you really have to go fast for. The C++, along with the optimizations that the compiler makes automatically, along with a bit of optimization on our end, should be fast enough for our needs. So anyway, we're going to use it because it's a low-level language, but it's still human readable. Okay. We're going to use it because it's a good language for object. That's not how you spell object. Oriented design and programming. OOD-OOP. We are going to be using object-oriented design and programming. I am a big believer in OOD-OOP. So yeah, when you're dealing with a complex system, OOD is pretty critical. It becomes more and more important. And as I progressed through learning C++ many years ago, I came to realize that it actually, the further on I got in the language, the more I realized how critical OOD is, really. It used to be the days long ago when you did procedural programming, basically just functions, functions that you called one after the other. Those days are gone. Unless your program is really simple, it's just it can't handle the complexity that we're dealing with anymore. You start to get to spaghettification of your code, and you lose control of it. OOD pretty much assures that you will never lose control of your code because everything is based around objects rather than tasks that you need to get done. Okay, so a lot of our design considerations will be along those lines of object-oriented design. Okay, so getting back to kind of the speed factor. So the other big language that's taken hold of these days is C#, which is kind of the C++ replacement program. Now, I love C#. There is a lot of good in that language, a lot of things that I like. However, unfortunately, I think one of its biggest downfalls is it's got automatic garbage collection. Now, our automatic garbage collection is great. It's really nifty not to have to worry about your garbage. However, unfortunately, the garbage collector does run completely out of your control, and it does have an effect on the speed of your program. It will slow you down, which makes it a no-starter for an engine. Okay, I'm sure there's probably ways to get around that in a modern environment, but the last time I used C#, it was still you could definitely tell when the garbage collector started to fire off. There was a definite lull in the program. All right, let's talk about some coding standards. If I could type. Okay. So first of all, as I've already stated, OOP. We've already talked about that. We will design all of our classes as objects. For the most part, I will use one file set per class. That's how I typically program. What I mean by a file set is one CPP file and one H file together to make a file set. Sometimes some other stuff, but those are usually the two. That's normally how I do things. Now, that's not necessarily always going to be true. There are some times when I'll put a little small classes together in one file set. They're highly related, especially classes that are front classes to each other. But for the most part, yeah, it'll be one class per file set. Here's an important one. We want to keep code duplication to a minimum. You really want to try to avoid code duplication quite a bit, as much as you can. Or one reason for that is, of course, if I have two pieces of code in two different locations that do pretty much the same thing, and then I change one or I debug one and I forget to do the other, I mean, suddenly you've got twice as much work to change one particular thing. So, okay, how do we keep code duplication to a minimum? Two ways. If you're duplicating code within a class, of course, the proper thing to do is to abstract out that code and drop it into a function that you can call from the two or more locations that you were writing that code in. Everybody knows that. I mean, if you know anything about programming at all, you know that. If you're writing duplicate code in multiple classes, that's a good place to, again, abstract that code out and put it into its own class. And then you can inherit that class into where you need it for other classes to use. Okay. Or alternately, you could use composition. That's maybe less useful than inheritance for the purposes of code duplication. So functions, and I'll call this helper classes. And by helper classes, I just mean small classes which are designed to abstract out heavily reused code. Okay, now that's not to say we can't have code duplication. In some cases, you might actually want to duplicate a certain amount of code for specific use of it in a class. You may not want to abstract out that code, just for reasons. I mean, that's not a complete hard and fast rule that we can't have any piece of code that does the same thing as another piece of code. You got to take it on a case-by-case basis, but for the most part, you want to keep it to a minimum. All right. We are going to be using inheritance and composition. Okay, so guys, this is not going to be a programming class or programming series. I'm not going to teach you how to program. So hopefully you guys know what this means, inheritance and composition. If you don't, I mean, it's not that difficult a concept, and you can certainly follow along. I don't mean to exclude anybody who doesn't know how to program. If you do not know how to program, C++ is actually one of those languages that's easy to learn, but difficult to master. It's like chess. You are certainly welcome to follow along. Again, I'm not going to be holding your hand going through what a class is and what inheritance is and what composition is and all that kind of stuff. However, having said that, I mean, you can, just by using context, you can figure out what I'm doing, right? It shouldn't be that arcane. So yeah, this is also known as, let's see, composition is, this is known as, also known as. All right, multiple inheritance. Let's talk about multiple inheritance for a minute. And this is where I need a draw tab. In inches, 5 by 11. Okay. Okay, guys, so multiple inheritance. So if you don't know what I mean by multiple inheritance, let's say we have 4 classes. Bear with me. I've got this tablet sitting in my lap, and it's a little bit difficult to use like this, but let's see how this goes. So let's, ooh, very nice. I can draw horizontal lines okay, but vertical lines seem to be a problem. All right, so let's say I've got a class. Okay, and this is class A, right? And we're going to inherit class A into 2 classes. And again, you'll just have to bear with my terrible drawing skills. This is going to be class B, and this is going to be the cleverly named class C. And we're going to inherit these guys into there. See, I'll try to draw the arrows. I'm using the standard UMD thing. Don't get confused if you don't know what this means. Class A is being inherited into Class B, even though the arrows are pointing the wrong way. That's just how UMD does it. I don't know why. It just is. And then we're going to do this. Class D, which is going to inherit both Class A, or Class B, and Class C. Okay, so I've done it this way to prove a point, right? And some of you who are familiar with multiple inheritance issues probably know exactly where I'm going with this. Let's say in Class A we've got a variable, and I'll just call it variable foo. Foo gets inherited into B. It also gets inherited into C, right? Because we set it up that way. When we go into D, what happens? Now you've got 2 of them. This is coming from B, and this is coming from C, right? And I don't have room to put the dots, but you get the idea. Okay, this situation right here is known as the diamond of death, the DOD. And this is the reason why multiple inheritance is basically frowned upon. Now, in this particular instance, it's very simple. A is inherited by B and C. B and C are both inherited by D. It's pretty easy to determine where the problem lies. And of course, if you don't know, the problem being, okay, if you refer to foo, what are you referring to? Are you referring to the one that comes from B, or are you referring to the one that comes from C? Nobody knows. And if you change one, it may not change the other one, right? And it may not really even be defined which one you're changing. So yeah, and now in this case it's very simple, but if you replace B with like a whole series of functions, or a series of classes, excuse me, and C with a whole series of classes, it becomes much more difficult to track down why your functions are not working the way you expect them to. Okay, so because of this, we're in general not going to be using multiple inheritance. In many languages, multiple inheritance is prohibited. In C++, it is not. You can use multiple inheritance if you like. For example, in C#, you can't use multiple inheritance. Having said that, there is one case, and let's see if I can draw this again. I'm going to try to stay off of this tablet unless I can figure out a better way to do this. When I'm doing this series, although I'm going to need it. I'm going to have to figure out some way of working with this tablet. It's not sitting on my lap like this. Okay. So let's just drop down inheritance lines. Forget the arrows. The arrows are confusing anyway. So we will sometimes have situations like this. And that's fine. There's nothing wrong with that. I will, from time to time, do things like this. Let's see if I can help A. Let's draw it a little bit bigger so I can write in here. help B, and we'll drop him in there. Now, you're going to say to yourself, well, hey, you just did multiple inheritance. And yes, it's true, I did. That is absolutely the case. The difference being that these little helper functions do not inherit. There's nothing coming in here, right? Put X's. There's no inheritance coming into helper functions. So these kind of things won't cause problems. This avoids any issues of diamonds of death and whatnot. That's not to say you can't have the same name. Like I could have Foo in here, right? And Foo in here as well. But the compiler knows these are different. And in fact, if I want to specifically reference them, help A and help B, Foo, I could do like such. Okay. All right. So yeah, I've spent enough time fooling around with that. So let's continue on. Let's go back over to our word. So we're going to say multiple inheritance is prohibited except for helper classes. And what I mean by helper classes is classes with no inheritance. Okay, I'm going to say something that some people don't agree with. And if you don't agree with it, that's fine. But it's just my natural way of coding. I prefer composition over inheritance anyway, which is opposite of what actually most programmers seem to prefer. Most programmers seem to prefer inheritance over composition. And a lot of professional programmers will tell you to prefer composition over inheritance. So for me, that's just natural. I mean, I just tend to go straight to composition in the first place. I actually probably underuse inheritance, to be honest. But we will use both. I mean, inheritance is important. You should be using both in your programs where they are necessary. But my natural instinct is always to go to composition first, which makes me different than most people, apparently. Okay. Let's talk for a minute about the rule of 3. And then I'm going to put /5. And then I'm going to put in parentheses 0. Okay, let's talk about this for a second. There are, how do I put this? As of the original version of C++, not the original, but let's call it the C++ version 98, which came out in 1998. I think that's right, 98, 97, something like that. There are basically 4 special functions for each class. There is that's not the constructor, the destructor, the copy constructor, and the assignment operator. The assignment operator. Okay. The rule of 3 says that ignoring the constructor, so this is not considered in the rule. But for these 3 right here, the destructor, the copy constructor, and the assignment operator, these are important functions. These are so important that if you don't provide one, the compiler will write one for you. There is a default destructor, default copy constructor, and a default assignment operator that are built in the background. You don't actually see them. They don't actually show up on your code if you don't provide one. Sometimes that's fine. If you're writing a very simple class that doesn't have any need of any deep copying, that can get away with shallow copies, the defaults are fine in some cases. But the minute you start putting in something that requires a deep copy, like for instance a pointer or any sort of, sometimes arrays, depending, but anything really that involves the heap, you're going to need your own custom version of these things. Okay, because the defaults won't do it right. They won't put together what you actually want them to do when a destructor is called or a copy constructor is called. So the rule of 3 says that anytime you need any one of those three functions, a destructor, a copy constructor, or an assignment operator as a custom operator or as a custom function, then you need all three. So yes, that's basically what that says. Now the rule of 5 makes it a little bit more complex because the rule of 5 actually came about with the introduction of C++11, which was finalized in 2011. And these are the move constructor, and the move assignment operator. Now this is a little more complicated. The rule of 5 isn't so much if you need any one of these, you have to make all 5. Basically, I think what it says is if you need a move constructor or a move assignment operator, then you need the other one. You need both or neither. But furthermore, if you need any one of those, then you need all 5. However, just because if you need the first 3 doesn't necessarily follow that you need the second 2 or the last 2. Okay, so you could have just these 3. You could have none of them, just these 3, or you could have all 5. Okay, that's basically what the rule of 5 says. Then there's the rule of 0. I'm not going to get too much into it because I don't agree with it. It basically says that classes should not be handling their own functions, that they should be abstracted out to a class that handles that specifically for them. Poppycock, I mean, if that's the way you like to program, fine. That's not the way I do it, so I ignore the rule of 0. I don't agree with it. That's just me. I mean, you guys are welcome to disagree with me. Okay, so brackets. Let's just cover brackets for just a second. I will be using a style of brackets called White Smiths. There's too many E's in that. How did we get 2 E's? I don't remember typing 2 E's. White Smiths. I think that's what it's called. Now, brackets, guys, is a thing that people get very religious about, and I understand that. When I first learned to program C long ago, White Smiths was used in one of the main books at the time that everyone used, and that's the style that I learned. Basically, let's pull up a compiler. Basically, it looks like this, right? There's your function, there's one indent, code goes here. I don't know, for int I equals 0, I less than 10, I plus plus. And then when I do an indent, it goes in and the code goes here, do some stuff, right? While, I don't know, I less than 4, and so forth. Something like that. Okay, you'll notice the code is lined up with the indentations. Okay, it's not a super commonly seen style, actually. To me, that's the most readable style there is, because so the brackets are surrounding the code, which is on the same level as the brackets. I mean, to me, that kind of represents as a paragraph to me, and I immediately know that all this code is related to each other, right? Whereas this is on the next level out. It's very simple. I can see right there that that's the next line of code. That's right here. A lot of people prefer this style. Here, I'll tell you what, I'll just copy this and we'll adjust it. Let's see, I think it's like such. They like to see, I think it goes this way, right? They like to indent like such, so that the code actually indents from the bracket. Now, I see that a lot. That's probably the most commonly used bracketing style. And I forget off the top of my head what that's called. To me, that's not as readable. I mean, just probably because I'm not used to it. Now look, and then of course there's the there's the other one. Let's do some function. some function so the compiler doesn't complain. What's the error? Oh, because I didn't define it. Yeah, whatever. Here, tell you what. There we go. Happy now? Should be happy now. No, you should be happy now. Save it. Did I misspell it? Well, look, I'm not here to really code. Just there. Could be in a pain. I probably misspelled it. Okay, some people do this, which drives me crazy. This is called K&R, like that. To me, that is the least readable code ever. I can't stand that kind of code. Nothing against people who have learned to code this way. I know there's a lot of people out there who do code like that. I personally don't like it. I mean, I can't figure out where the brackets are supposed to go, right? I have no idea where this bracket ends. I mean, the compiler's telling me because it's highlighted it. It's way down here. Okay, to me, that makes no sense. But some people like to code that way, and I see a lot of code that's done that way. For a long time, I was reading a lot of code, and that's a very common style. I will point out that the only difference between Whitesmiths and K&R is a single function, is a single return of the return key. So, I mean, it's not so different, right? All it takes is one return key, and people get all religious and up in arms about it. So, anyway, that's a quick overview of bracketing styles. There's others, but I mean, yeah, this is the one that I like to use. But by all means, if you're going to follow along, use the bracketing style that you like to use. Whatever you find most readable, that's what you should be using. I mean, because readability is key, guys. That's probably it. It's more important to be readable almost over anything else. If your code is readable, it's not going to have as many bugs. And that's just how it is. The less readable your code is, the more bugs you're going to have. I have seen code where I saw somebody do stuff like this. It's just var x equals 0.3. Yeah. Why is var not working? Fine. Float. Whatever. I could smack anybody who does that. Okay? That's ridiculous. What's the difference there? Just a decimal point. How readable is that code? It's not readable at all. It's terrible. Why would you do that? Put in a damn 0 so that it's very obvious that this is 0.3. Anyway, I don't mean to go off on a rant, but make your code readable. Make it so that not only you can read it, but everybody can read it. If you make your code readable, you do not need to comment every line of your code. I've seen people who've done stuff like, you know, set x to 0.3. Come on. That's self-commenting code, right? You can just look at this and say, yeah, okay, there's x, it's 0.3, right? If you make your code readable, you don't have to do stuff like this. For some reason, I'm hitting a bunch of extra keys. Comments really can be much higher level than that, right? They should be much higher level than that. To explain the overall purpose of a function or the overall purpose of a block of code, you do not want to write comments line by line. That's ridiculous. And you shouldn't have to. If your code is well written and readable, you don't need to write comments for it. So yeah. Anyway, let's move on. I've spent probably more time on that than I should have. And actually, this video is getting long. Okay, we're going to be using Visual Studio 2015, which is this what I've got out. It's free, guys. You can get it. So here it is, guys. www.visualstudio.com/downloads. And let's see, it's right here. Visual Studio. And there it is. It's a free download. Go ahead and get it if you want to follow along. So I'm going to close this. I'm not going to do that. So the one thing about Visual Studio, the version that you just downloaded, is it no longer includes C++ as a module. The way it's no longer a default. The default Visual Studio has C#. I think it has Basic. It has a lot of stuff in it, but it does no longer include C++ anymore. I think Microsoft would really like C++ to phase out in favor of C#. Right here, if you're looking for the Visual C++ compiler, Visual C++ is not installed by default. When installing, be sure to choose custom installation and then choose the C++ components you require. Or if Visual Studio is already installed, choose File, New, Project, C++, and you will be prompted to install the necessary components. So it should install as soon as you hit File, New, Project, C++, which would be the first thing you do anyway. File, New, Project, and then C++. Okay, so a lot of this won't be here, but this should be here. It might be under online. Yeah, right here. That's where you would have to go. And then, because it won't be under installed, this won't be here, right? Because it's here for me because I've already done this, but you have to go to online and then Visual C. And then it'll install it, and then it'll be here, and you can actually do it yourself. Okay? So just to let you know, that's where you get it, and that's how you install the C++ module. Okay. So, yes. What's going on here? So Visual Studio 2015 is what we're using with C++. Okay, enough of that. Let's talk just for a minute, and I know this video is getting long. Engine features. So up to this point, unless you completely hate everything that I've said so far, you still have no idea if this series is going to be right for you. And why is that? Because this is not... Okay, there we go. Because we haven't talked about the actual engine at all. So you know how I'm going to code it, you know why I'm going to code it, you know what language we're going to code it in and why, but you don't know anything about the engine. So what engine are we going to design? Now, there's a couple of schools of thought on game engines, and I've seen both used. One is to basically program a large library of tools for the game developer to use, and then just give them a couple of what are called magic functions that are hooks into the engine itself, and said, okay, there you go. Write your game using C++ or C#. Here's the hooks that you need to get to our functions, the functions that'll help you. Go for it. That's one school of thought. The other school of thought is to provide kind of a front end to the developer that has kind of a user interface. It probably has a level design field. It has various informational fields that tell you where your assets are and that kind of thing. So I've seen both of these used. The one we're going to go with is the one with the front end. Okay. In my view, you want to give the game developers have a hard enough job, right? You want to give them as many tools as you can to help them with their task. I mean, the more you can help them, the better off they're going to be, the easier time they're going to have, right? So, yeah, so we're going to have a front end. This is going to just very broadly consist of some resource, placement, UIs, level design, etc. It's here, resource lists, and so on. There's a lot to that, actually, but we'll just make it very general. We're going to have a drag and drop sort of interface. So what I mean by that is the ability to drag resources into the particular developer's game via the Windows kind of Explorer, right? So if I had some resources in here, I could grab one, drag it into my user interface, and it would become part of the list of resources that are available to the user. Also, dragging from the list of resources into the level design area is another one for that same kind of deal. There will be an organizational system. This is important. Let's even go further and call it an automatic organizational system. You guys, if you've never actually worked on a game before, you'll be amazed at the number of resources that are necessary to put a game together. By resources, I mean bitmaps, models, scripts, animation, parameters, sounds, huge materials. I mean, there's a huge number of items that you need to worry about. And it can very, very quickly get overwhelming. And if it's not kept organized and in some sort of reasonable system, you're going to start losing stuff, right? So, yes, it is critically important that there's some sort of organizational system in place. And if we can automate that organizational system and make it flexible enough to meet the developer's needs, then great. That's one less thing that they have to worry about. So we will work on that. There's going to need to be some sort of scripting interface. I haven't entirely decided how we're going to do this yet, but the scripting language that I'm leaning towards is C#. So I just got finished with all this business about C++. That's how we're going to code the engine. We're going to use C# for the scripts. We may use a modified version of C#. I don't really know yet. We'll figure that out a little more when we get there in a little more detail. I have some general ideas, but I think I want to stick with C#. We'll see how it goes. Again, there's that whole garbage collection thing that's a little bit worrisome, but we'll see. In any event, the scripting system has to expose variables to the engine. So what do I mean by that? You'll write a script and you'll attach it to some object that exists in your world. This is when you're designing the game. And you want to have some variables associated with that script that you can change right in the engine rather than having to go back into the script and change them. That way it's more kind of hands-on at runtime kind of changes that you can make to that object rather than having to stop the game, go back into the script, change some scripts, run the game again and see where it goes. And yeah, you don't really necessarily want to do that. If you can expose those variables directly in the engine and put them up on the user interface somewhere where the user can actually change them in real time, it makes their life a lot easier. Okay. We're going to need some system for handling the GPU. What do I mean by that? What I'm talking about there are shaders. And what kind of shaders are we talking about here? There used to just be two. There was the pixel shader, also known as fragment shader. This runs one time per, let's call it fragment. That's actually a more accurate term than pixel. Okay, so I probably maybe shouldn't have started with pixel shader. I should probably start with the vertex shader. Okay, so you have a model. It's a model that you've built in Maya, say, or Blender, or one of those 3D modeling packages, right? That model consists of triangles, or it should consist of triangles. And so each of those triangles, I'm going to simplify here. Each of those triangles has 3 vertices. That's actually not true, but let's not get into it. That's not part of my point. For every vertex that's drawn, the vertex shader runs once. And the vertex shader is a small program that runs on the GPU. And it tells the GPU how to deal with that vertex. Where does that vertex end up on the screen? It does some other stuff as well, but okay. Remember, so it's sort of like scripting, except you're not writing script for the CPU to run. You're writing script for the GPU to run. The pixel or fragment shader is kind of the similar deal, except instead of running once per vertex, it's running once per fragment. I don't really want to get into the difference between fragment and pixel at this point. Again, it's a bit of a subtle difference. Fragment is the more accurate term. We'll just leave it at that. Anyway, it runs once per point on the interior side of every triangle, right? I could draw pictures, but that's as much as you really need to know. These are both programs that run on the GPU, and we need some way to write those programs. They're attached to materials, ultimately. So in recent times, there's been a couple of new shaders that have been developed that are kind of less used, but we should still support geometry shaders and something called a tessellation shader. This one came first. This one came up a few years ago. This is good for shadow volume. It takes your geometry as input and it spits out another piece of geometry. Okay, and it could be a modification of the original geometry. It could be something like a shadow volume that's a new piece of geometry that's rendered in addition to the original piece of geometry. A tessellation shader, kind of similar to a geometry shader. Tessellation has to do with level of detail. Basically, so if you think about it, suppose I have a very complex model. It's 20,000 triangles or something. And now up close, it looks great. It looks great up close. It draws in all this great detail. It's beautiful. Now I'm going to draw that model way off in the distance. And so on your screen, if you think about the screen pixels, it's taking up 18 pixels high and 7 pixels across. Do I need to draw 20,000 triangles to draw something that's 18 pixels high? No, I do not. So that's called level of detail. And the tessellation shader can help you with that by automatically reducing the complexity of your models that are that are far away. And it's done on the GPU, so the CPU doesn't have to worry about doing it itself. There are systems that do this on the CPU, or you can actually swap out models that you've already done. That's the way things used to be done, and I think to a large extent that's still the way things are done. But theoretically, the tessellation shader should do this actually almost for free because the GPU is doing it rather than the CPU. Now, to be honest, guys, I personally have never used a geometry shader or a tessellation shader in my life. The geometry shader was kind of new when I sort of phased out of game programming. And the tessellation shader is completely new. I've never seen one ever used. So I don't even know how widespread of support they have. It's something we'll find out. Okay. So let's back up. There needs to be in the engine some sort of game preview mode. You need to be able to run the game directly through the engine design user interface so that the developers can get instant feedback on what they're doing. And then, of course, there's some sort of game export functionality so that once the game is ready to go, they can export it out. It becomes its own separate thing. It doesn't need the engine UI components anymore. It just needs the game components with the engine backend in place. So, of course, we need an engine backend. So you've got both a back end to the engine and a front end in our particular case, where the front end is kind of the user interface, the drag and drop, the design. The back end is there to support the game itself, the part that actually runs the code, shows stuff on the screen, runs the script, and all that kind of thing. Okay, so those are, I mean, that's super broad. I mean, I could go on for days and days on engine features, but I just wanted to give a really broad overview just in case for those of you who might not be interested in this particular kind of engine. If you're more interested in, the other kind where you're just giving them functions and letting them go at it, then that's a whole different thing. So you may not agree with my decisions here. So if you don't, then this series may not be of any interest to you. What can I say? So yeah. Let me put, just up in here, I'm going to throw in an extra thing. We will need some sort of resource database, which includes metadata about the resources. this kind of goes along with the organization system. Basically, we need to know for every resource where it is, kind of in a file system, what it is, where it's being used, how many times it's being used in the actual game. So when a developer drops a resource in from the operating system file system, it'll have been used 0 times in the actual game until that developer takes that resource and then drops it into something that's used in their game, right? This will also be useful for materials, because materials actually are a conglomeration of resources. They're a conglomeration of shaders, pictures, files of some sort, things like that. So yeah. So yes. Speaking of which, actually, let's go ahead and put that in as well. We'll need some sort of materials editor directly in the engine, because materials themselves can get quite complex. So a lot of our resources are coming from outside sources, like Photoshop for picture files, Maya or Blender, or 3D Studio Max for models, maybe Audacity or some sort of studio program for sound. So they come from outside programs, but materials, there's nothing really, there are no material building programs. I mean, maybe there are, but you don't really need them. You'd use those resources, picture files, shaders, and you put them together, and that's a material. And then that material goes on top of a model. All right. So there's some sort of material editor that we're going to need in there. Also, probably will be useful to have some sort of interface. Let's put in the UI editor. This is the interface, the game interface is what I'm talking about here. So if you think about a game, it usually has some sort of HUD or some sort of interface to present to the player. Most games have to have some kind of thing. At the very least, they have to have some sort of startup menu, right? Start new game, load and save and all that kind of stuff. So we need some sort of editor to deal with that. And that can be quite complex, actually, because you got to deal with multiple resolutions. Do you want to do interface scaling? Do you not want to do scaling? How do you handle different resolution formats? That kind of thing. So it can be quite complicated. So we'll deal with that as kind of its own thing. All right, so those are the major features that I wanted to get in. There's a huge ton more. I mean, there's just, we could go on forever talking about engine features that we want, but I just wanted to get an overview, just so you know kind of where I'm going with it, and whether this is the kind of engine that you want to follow along with. In how we do this. Okay, I know this video is getting long, so I'm going to stop. What we will do in the next video is we will start discussing the first major system that we're going to put together, which is going to be the memory manager. So just kind of as a guide, there'll be a video on design, kind of similar to what we're doing here, only focused more on a particular system. Why we need it, what problems we want it to solve, you know, how in general we want it to work. Then we will start drilling down in subsequent videos into specifics about what functions we need, maybe what variables we need. And then we'll do a video on implementation, actually writing the code. Okay, so that's kind of the idea. All right, I'm going to try to do these videos weekly, probably release on a Saturday or Sunday. So I will now be up to 4 videos a week, because I don't want to do 5 videos and only be releasing 3 a week. That's I don't want this to cut into the game videos, in other words. So I will try to do these weekly. No promises though, because sometimes some of these videos are going to require some research. Some are going to require a little bit of exploratory programming. And I may not be ready for a particular episode. So if it doesn't go up, don't worry. It'll probably be up the next week. So yeah. All right. Okay, guys, we'll stop here and we'll pick this back up in the next video. I will see you guys in the next one. Thanks a lot.